Alright, let's look at the nth order homogeneous linear equations with constant coefficients. Alright, this is a third case, complex roots. Alright, let's say r is equal to a plus or minus bi, which is a complex number. They are complex conjugates of each other. Alright, then the solution is going to look like this. Alright, so y equals e to the ax times c1 cosine of bx plus c2 sine of bx. All right, where did that come from? All right, so to explain that, we need to look at the Euler's formula, which says that e to the I theta is equal to cosine of theta plus I sine of theta. Alright, so if you have a root, which is a plus or minus bi, so we would expect the solution to look like e to the a plus or minus bi x, right? So I'm going to split this into, right? So you have a e to the ax times e to the, right, so we're going to have a plus or minus, I'm going to put the I first, bx, right? So you can use the Euler's formula to split this into a cosine and sine. So this is going to be, so we still have e to the ax, right? So this is going to give us a cosine of bx, because this is like theta. Maybe I should do that. So this is like a theta here, right? So it's going to be cosine of bx. And since you have a plus or minus, so I can probably put plus or minus here, I sine of bx, right? So all they did was put the, that's the constant c1 and the c2 in front of cosine and sine, and let c2 absorb the I in front, because I is a constant, right? So that's where this comes from. All right. Then why don't we look at the this following example? All right. So we have this differential equation. So let's solve this one. All right. So write down the characteristic equation for this one. We would get r squared minus 6r plus 13 is equal to 0. Right? So I'm going to use the quadratic formula. So r is equal to negative b, so it's going to be positive 6 plus or minus square root of, right? So 6b squared would be 36 minus 4 times a is 1 and c is 13, and over 2 times a, so 2 times 1, right? So what's this? So 4 times 13 would be 52, right? So 36 minus 52 would be, let's see, 16. All right, so it's negative 16. So therefore, we are getting 6 plus or minus. All right, so negative 6 square root of negative 16 would be, let's see, 4i. So 4i and divide by 2. So we're getting 3 plus or minus 2i, right? So therefore, the general solution of this differential equation will be y is equal to e to the ax, a is 3 in this case, so 3x, and times c1 times cosine of b is 2, so 2x, plus c2 times sine of 2x. Right? So got that. So that is the solution of the given differential equation. Oops, sorry, that's not what I wanted to do here. I just want to box that out. All right, that's it. I hope that this was clear.